In example 3.1, we're looking for quite a few things. Let's start with the sample space. Remember that the sample space, as defined in the book, is the entire set of all possible outcomes. So in this example, it says the sample space is the whole numbers starting at 1 less than 20. So then the sample space here, we would list all the numbers starting at 1, 2, 3, 4, 5, and keep going. And then I'm going to decide, am I including 20 or not? It says start at 1 and less than 20. So since 20 is not less than 20, I am going to stop at 19. Next, it says let event A, the even numbers, and event B, the numbers greater than 13. So event A is all the even numbers in our list. So I'll use a different color. Here we'll have 2, 4, 6, 8, 10, 12, 14, 16, and 18. B is the event that their numbers are greater than 13. So not equal to 13, but greater. So the numbers greater than 13 on our list are 14, 15, 16, 17, 18, and 19. So letter C is asking us for the actual probability of A and the probability of B. So what we do is we count now. We're going to count the total number of cases in our sample space. So I have 1, 2, 3, 4, 5, 6, all the way up to 19. So that gives us a total of 19 outcomes. In our space for A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 outcomes. And in our sample space for B, we have 1, 2, 3, 4, 5, 6 possible outcomes. So let's start with the probability of A. The probability of A is going to be 9 possibilities for A out of 19 total possibilities. So the probability of A is 9 out of 19. The probability of B is going to be there are 6 outcomes, so 6, and the total possibilities is 19, so 6 out of 19, and we can leave them as a fraction. Letter D. There's 2 questions here, A and B, A or B. And means what do they have in common? Or means just list everything without repeating our numbers. So let's look at A and B. If I were to combine the lists A and B, where would these 2 lists overlap? I see that these lists have 14, 16, and 18 in common. 14, 16, and 18 in common. So when I say A and B, I'm just listing those common values. So this one has a common value of 14, 16, and 18. Now when we're looking at A or B, we're looking at the possibility could be anything from A or it could be from B. Now, because there are repeaters, we will not include that number twice. So like 14 is a repeater, but I'm only going to put it once in my list. So our list is going to be, let's list all of A. We have 2, 4, 6, 8, 10, 12, and then 14 is in common with B. And then B has 15. 16 is in common. and then 17. 18 is in common, and then 19. So basically, this is a list of all the numbers in our sample space, excluding the number 1. Now, the probability is where we determine the number of possibilities out of the total outcome. So, I know it's going to be out of 19 for both of these. I just have to figure out what this top part is. And that's not a big deal because I've already listed them in D here. So for A and B, we have 1, 2, 3. So that would be 3 out of 19. For A or B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 19. So you can see that the probability has to do with two different lists. In the bottom, we have the entire list of the possible outcomes, and on the top, we have the specifics of what our, I want to say, point of interest is. Now, letter F. This little apostrophe means complement or not in A. So this little apostrophe means what are those values in our total here that are not listed in A? And since A was all the even numbers, then the complement of A is going to be all the odd numbers because those are the ones that are not listed in A. So for A apostrophe, or the complement of A, we're going to list those odd numbers. 1, 3, 5, 7, 9, 11, 13, 15, sorry, I'm writing it kind of small, 17, and 19. Now the probability of the complement of A is going to be, let's count up our list here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 values in the complement of A, so that would be 10. And our sample space is still 19, so 10 out of 19. Now, look at letter G. Letter G shows us a very important property here. If I take the probability of A, which is 9 out of 19, and add it to the probability of the complement, which is 10 out of 19, we get 19 out of 19, which is exactly 100%, or the probability is equal to 1. All right, letter H is the one that always gets the most questions, and it's when we have this line. This line means it is a conditional probability, meaning that we're looking for the probability of B under the conditions that A happens first. So here's how you solve this. We start by writing the formula. And the formula here is going to be, for this one, it's the probability of A and B. And then we're going to divide it by the probability of B. The second one, probability B given A, is going to be probability of A and B. Except this time, instead of dividing by the probability of B, we're dividing by the probability of A. So we already have all these numbers. We did them in the beginning parts of this section. So let's just write it out now. Let's start with this first one, the probability of A given B. So probability of A and B, we did it right here, is 3 out of 19. So 3 out of 19. Divided by the probability of B. Probability of B is 6 out of 19. If I divide this out in a calculator, or even by hand, we get the probability of 3/6, also known as 1/2. Now let's try the probability of A and B divided by the probability of A. So the probability of A and B is still the same, 3 out of 19, divided by the probability of A. The probability of A is 9 out of 19. We could divide this on a calculator or do it by hand, but our result ends up being 3 out of 9, or when we reduce this, 1/3. The second part asks, are these equal? Looking at my fractions here, 1/2 is not equal to 1/3. So my answer to this would be no, they're not equal.